there's two types of redox titrations that you need to know about at A level. One of those involves iron 2 plus ions, Fe2 plus, which I've got in the solution here, reacting with potassium manganate 7 from a burette. Importantly, it's essential to acidify this using some dilute sulfuric acid. So I've poured that in from a measuring cylinder. That does not need to be measured accurately as long as it's an excess, because it doesn't alter the moles of Fe2 plus or the manganate. It's just there to drive the redox reaction in the correct way. So this just works as a normal titration would. I'm going to pop this under the burette and start that burette going like so. Notice that there's a colour change from the very deep purple manganate ions. They form a very, very pale pink Mn2+, but they're essentially colourless. And the Fe2+ oxidizes to Fe3+, but again, it's a very, very pale coloured solution. So the colour change that we're looking for, and it looks as if we're getting reasonably close to that now, is when the final drop of MnO4- is added. One extra drop will cause the whole solution to look the kind of very pink colour that the very dilute MnO4- solution looks. So if I keep swirling like so, eventually we should get to the situation where one drop just turns that colour permanently pink. I suspect we're almost there. Just like that. Okay? So permanent pink colour. There's two types of redox titrations you need to know about at A level. In each case, we use manganate in the burette, so potassium manganate 7 in the burette, and whatever's in the conical flask is the reducing agent. So in this example, I'm going to use ethanedioate ions, C2O42- ions, in this beaker of sodium ethanedioate. So I'm just going to pipette an aliquot of that. Oops, need to be a bit faster than that. Pipette an aliquot of this into a conical flask, like so. But for this one, unusually, this has to be heated up in order to work. So I'm going to pop that into the conical flask just in the usual way. Then I've got a hot water bath of water, just hot water from the kettle over here. I'm going to leave that sitting in the hot water bath for several minutes whilst I go away, do something else, and then I'll come back to this titration in a while. So the second of the two types of redox titration you need to know about is ethanedioate ions reacting with potassium manganate 7. So I pipetted some ethanedioate solution into this conical flask some time ago and just popped it in a really nice hot water bath, that hot water from the kettle. I'm going to take some sulfuric acid, dilute sulfuric acid, and just add about 25 centimetres cubed of that into this ethanedioate solution to make sure that that's fully acidified to drive that redox reaction, but it doesn't affect the number of moles of anything, just like with the Fe2+. Then I'm going to pop this underneath the manganate and add a few centimetres cubed nice and quickly. Now you see straight away that this does not change colour as quickly as the iron 2+ one did. There's an instant colour change of the iron 2+, and this is a much slower reaction, which is why I've heated it up in the first place, to try to speed it up a little bit. In fact, I might just bob that back into the water bath. But this should eventually change to being colourless. So this is not the end point of the titration just yet. Interestingly, when the manganese 2+ ions are produced by reducing the manganate, the MnO4- reduces to Mn2+, which are pretty much colourless. They're very, very pale pink, but almost colourless. Those Mn2+ ions start to catalyse this reaction. So this is an example of an autocatalysis process where one of the products of the reaction also catalyses that reaction. So in other words, it speeds everything up, and you can perhaps see that that colour is starting to change. So eventually that will then go nicely colourless when that catalyst has started to work its magic, like so. And now that some of that catalyst has built up, I can continue with the titration as normal, and it starts to change colour a lot more quickly. So you've just got to be a little bit patient with this one and just allow it to build up the catalyst until the point where that change in colour is almost instantaneous, or indeed is instantaneous, and then continue to add the manganate, just like in the Fe2+ titration, until one extra drop just makes that colour change permanently. It just works in the same way.